paracetamol, the famous painkiller, ever piqued your interest on how it's produced? This thought could have crossed your mind as you consumed that tiny white tablet to ease a throbbing headache or cool down a fever. Internationally known as acetaminophen, paracetamol is a typical household remedy, a core item in numerous medicine cabinets. But what exactly is this seemingly magical pill that grants us liberation from pain and unease? Essentially, paracetamol is a chemical compound, a mixture of raw elements creatively undergoing a sequence of captivating chemical transformations. It's a procedure that marvelously encapsulates modern pharmaceutical science, fusing the genius of chemistry with the practicality of medicine. You might be wondering, why is this significant? Gaining knowledge about the creation of paracetamol doesn't just satisfy our intellectual cravings, but also makes us value the intricacies behind something we generally overlook. Hence, prepare yourself as we dive into the intriguing procedure of making paracetamol. To begin with, we need to understand the raw materials used in making paracetamol. Now, the key ingredients, or the star players of this process, are two compounds, p-aminophenol and acetic anhydride. P-aminophenol, the first player, is an organic compound that serves as the base in our paracetamol production process. This compound plays a crucial role in the transformation that leads to the creation of paracetamol. On the other side, we have acetic anhydride, the second player. This is an acid anhydride derived from acetic acid. In our process, it acts as an acetylating agent, facilitating the chemical reaction that leads to the formation of paracetamol. Both these compounds, p-aminophenol and acetic anhydride, are vital to the production process, each playing its unique role in the creation of our final product, paracetamol. With our raw materials ready, we can now initiate the journey of paracetamol production. Now that we have our ingredients, it's time for some chemistry magic. When it comes to making paracetamol, the two key players are p-aminophenol and acetic anhydride. Now, let's imagine these two ingredients as dancers at a ball, ready to perform a waltz of chemistry. The dance begins when p-aminophenol and acetic anhydride share a dance floor, a flask in our case. Here they engage in a complex dance, known in the chemistry world as an acetylation reaction. The temperature of the ballroom is crucial, kept around 90 to 110 degrees Celsius. Too hot, and our dancers may get a bit too excited and create unwanted byproducts. Too cold, and they might not dance at all. The dance is further facilitated by a catalyst, usually a weak base like sodium bicarbonate. This catalyst is like the orchestral music guiding the dancers, speeding up the dance without getting involved directly. It helps p-aminophenol and acetic anhydride react faster and more efficiently. As they whirl around the flask, a bond forms between the dancers, creating a new compound, paracetamol. This bond is the result of p-aminophenol donating an amine group to acetic anhydride. The acetic anhydride in return gives off a water molecule, which is the equivalent of a polite bow at the end of a dance. This dance, or chemical reaction, is a delicate balance of conditions from temperature to the presence of a catalyst. Change one thing and the whole dance could end up in chaos. But get it right, and you create a beautifully orchestrated performance that results in the production of paracetamol. This dance is not just a fascinating spectacle, but also a crucial part of the pharmaceutical industry. It's the magic that transforms simple ingredients into a compound that has been relieving pain and reducing fevers for over 100 years. There we have it, the chemical reaction that forms the basis of paracetamol production. But wait, we're not done yet. Our product needs some cleaning up. You see, after the chemical reaction, the mixture we get isn't quite ready to be popped into a pill bottle. It still contains impurities that need to be removed. So how do we do that? Well, through a process called purification, of course. The first step of purification is crystallization. This is where we cool down the mixture slowly, allowing the paracetamol to form crystals. The impurities, on the other hand, remain in the liquid form. Now, why does this happen? It's because the paracetamol has a different solubility than the impurities. As the temperature drops, the paracetamol is less able to stay dissolved and begins to form crystals. Once we have our crystals, we need to separate them from the liquid. Enter filtration, the second step of the purification process. This is where we pass the mixture through a filter. The liquid, along with the impurities, passes through while the crystals of paracetamol get caught in the filter. And voila! What we're left with are pure crystalline paracetamol, but we're not quite done yet. These crystals are then dried to remove any leftover moisture, ensuring that our paracetamol is as pure as it can be. So you see, it's not just about mixing a few chemicals together. A lot of care and precision goes into making sure that the paracetamol you take is safe and effective. After the purification, we are left with pure white paracetamol ready for use. Finally, our journey ends with the final product. The pure paracetamol that we procured from the purification process is now ready to be transformed. But how does it become the tablet we're all so familiar with? Well, the pure paracetamol is first mixed with a concoction of binders, fillers, and lubricants. These help the tablet hold its shape, increase its size for easier swallowing, and allow it to smoothly release from the machines during production. Once thoroughly mixed, this mixture is then compressed into the familiar tablet shape. But that's not all. Paracetamol can also be processed into other forms. It can be dissolved into a syrup for children, encapsulated for controlled release, or even combined with other active ingredients to tackle multiple symptoms at once. And let's not forget about quality control. This is a critical step that ensures the safety and efficacy of the final product. Each batch of paracetamol is rigorously tested for purity, strength, and quality. Any batch that doesn't meet the stringent standards is discarded, ensuring that only the best reaches your medicine cabinet. So the humble paracetamol tablet is not as simple as it might seem. It's the culmination of a complex chain of chemical reactions, meticulous purification, and careful processing. So next time you pop a paracetamol, remember the intricate process that brought it to your medicine cabinet.